Hi and welcome. I'm Aziz from Siemens Digital Industry Software. In this video, we'll be looking at design capabilities within NX. NX comes with a wide range of modelling tools, giving you complete control over the appearance of your geometry. Everything from 2D, 3D and surface modelling capabilities are at your disposal to bring your concepts to life. Here's what you can expect. We'll introduce the dataset used throughout the video, the coffee machine, create the 2D blockout of the concept using NX Sketch, performing base operations to construct the 3D body, using synchronous modelling to reorient the digital screen, using detailed modelling to create split bodies, using algorithmic modelling for textured patterns on the coffee bean hopper, adding a logo and adding materials to the model. We're going to be focusing on the creation of a new coffee machine, designed by an established manufacturer. They've already created a range of successful products for cafes and restaurants, and they now want to take this success and apply it to the consumer market. Here's the coffee machine. While suitable for a more industrial setting, a more precise set of design requirements are needed to ensure it appeals to the manufacturer's target demographics. The manufacturer is happy with the technology around their existing industrial machinery. The internal components are all prepped for reuse and have all the relevant material, supplier and cost data attributed to them. Focus groups indicated that consumers want a coffee machine that has a sleeker finish, is a lot easier to use and is more appropriate for a home setting. The goal is to use this set of internal components already created and envelop them in a new, reworked exterior shell. Reworking the model begins before we head into NX. The traditional method of design conceptualization is to draw ideas with a pen and paper. It's of course a tried and tested method to ensure the designer captures the design intent with accuracy. Whether it's hand-drawn sketches or utilising the touch capabilities within NX, these initial ideas can easily be worked up into 3D forms. We need to remember that the new design must appeal to a different market than its industrial counterpart. On top of this, we need to stay true to our original concept for the coffee machine. With this in mind, we can work the model up from scratch using basic modelling operations within NX. We can start by extruding the sketch profile, which will create the foundations for the new coffee machine. The extrusion created from the sketch curves can be altered until we're happy with the dimensions. We also need to add further extruded bodies to outline the basic shape of the coffee machine using the same technique. Now we can take a look at modifying the digital screen face. To do this, we will use synchronous modelling. Synchronous modelling is a powerful set of tools within NX. It enables direct manipulation of solid and surface geometry without the need to fully understand how a model is constructed. Additionally, engineers are able to modify existing designs quickly and easily. It's a simple step. Select a face on the existing block and make it coplanar with the face of the lower part of the machine. Now we have the basic shape defined, we can start to add detail, such as softening the sharp edges with blends. NX has a range of blend options to capture design intent. Here, we start by adding edge blends. We're able to blend multiple edges on several solid bodies with one feature, and use selection prediction to speed up the process. Next, we want to refine the face which will house the screen. The face is currently vertical and may prove more difficult to read than an angled one, so we'll use synchronous modelling again to adjust the angle. You can see how quickly this can be done with all the existing topology updating, including the blends adapting to the change. Our coffee machine is starting to take shape, but we can refine it further. Part of the brief was to make the machine more eye-catching, so let's look at how we can do that. The blends already added have tangent continuity, which is fine, but can still show a sharper transition than other forms. This can be illustrated with reflection analysis. Notice the sharp transition between the blend edges. Let's change the blends to ones that have curvature continuity. To do this, we simply edit the blends, change the type, and then the part updates. Now when we look at the reflection analysis, we can see there is a far smoother transition. As previously mentioned, NX has many powerful tools for refining solid shapes. Another one of these features is blend corner. This command allows you to take an existing blend condition and adjust it to give a smoother, more pleasing form. It's a simple process. All we need to do is select the 3 blend faces near the corner and then fine-tune the resultant blend using drag handles. Again, we can also analyse the blend corner with reflection lines. Now, the top casing for the coffee machine will be manufactured using injection moulding. And to do this, it needs to be split into 2 halves. We can use a datum plane to simulate the split line, and this will divide the body into 2 pieces. Next, we'll continue to add detail to the top casing of the machine. To do this, we'll add a wall thickness using the shell command option. We'll input the wall thickness required and then select the faces we want to shell. It's as simple as that. Many consumer products have repeatable patterns in their designs, some of which can be very complex. These could be a pattern of holes for cooling purposes, or 3D textures to create visual interest. We're going to look at the coffee bean hopper that sits on top of the machine and add a texture to it. Doing this manually is time-consuming, so let's look at how algorithmic modelling can do this and make a feature that can be reused. You can see we already have an algorithmic feature in the part that's suppressed. We can take a look at how this feature was defined, which takes us into the logic editor. Algorithmic features are based on logic rules, which are defined by connected nodes. During rule creation, NX is automatically creating a feature dialog in the background, and that will be presented when the feature is added or edited. All rules can be saved and added to the NX reuse library for other engineers to take advantage of. Now that you've seen how this feature was created, let's unsuppress the features in the lid part and see what we have. Notice what the current pattern looks like. We can also modify the feature so that we have a completely different one if we wanted. Finally, we can use a more photorealistic display to see exactly how the pattern would look with different materials applied. The manufacturer also wants to customize their new product by adding a coffee bean logo to the machine housing. Draw Shape in NX enables designers to construct curve profiles directly onto 3D forms. And this is what we'll use to sketch out the shape of the coffee bean. Here you can see we simply draw the approximate shape we want directly onto the coffee machine housing, which can then be refined by dragging the profile to the required form. Now we have our finished coffee bean profile, we can use this to complete the logo. We'll use the variable offset face feature to construct the final logo. All we need to do now is simply select the faces for the logo and then the draw shape curves as the boundary. Next, we add an offset and the logo is added to the housing. We've also added some edge blends to soften the sharp edges. And with that done, the coffee bean logo is now complete. Our surfaces are modelled and additional detail has been added. We've also used algorithmic modelling to create different versions of the coffee bean hopper. We also want to make sure we add materials to the coffee machine at this stage. By doing so, we'll start to get an understanding of what the final product will look like. As the goal is to create multiple iterations of the model in different styles, it's worthwhile adding different colours. By doing so, we're ensuring that the design team are fully prepared and ready for an in-depth design review later on in the workflow. Within NX, there are over 1,000 out-of-the-box materials to choose from. All the materials are sorted by type, such as plastics, metals, and fabrics. For the coffee machine, the Sustainability Impact Analysis tool indicated that ABS plastic is the most suitable material, so let's apply it to our model. There are several colour variants of ABS plastic that you can apply. However, if none of these are suitable, we can manually select the part or parts and edit properties, such as colour and material roughness. With the material applied, design engineers are now able to share images of the initial concept. Having a range of tools available to you ensures that you can accurately create your model. We're really excited to see how you'll implement these features into your workflow to create truly unique styles. In the meantime, if you missed our June 2023 update for NX, click on the link in the description. And whilst you're here, subscribe to our channel to see all the latest updates about NX.